lesson 4-7, transformations and matrices. The big idea is that the product of two matrices corresponds to the composite of the transformations that the matrices represent. Properties of 2x2 matrix multiplication. Multiplication of 2x2 matrices has some of the same properties as multiplication of real numbers, such as closure, associativity, and the existence of an identity. Closure. The set of 2x2 matrices is closed under multiplication. Closure means that when an operation is applied to two elements in a set, the result is an element of the set. From the definition of multiplication of matrices, if you multiply 2x2 matrices, the result is a 2x2 matrix. Associativity. Multiplication of 2x2 matrices is an associative. For any 2x2 matrices A, B, and C, it can be shown that A, B, parentheses, C equals A, parentheses, BC. You are asked to prove this in the questions. Identity. The matrix I equals 1, 0, 0, 1 is the identity for multiplication of 2x2 matrices. Definition of composite of transformations. Suppose transformation T of 1 maps figure G onto figure G copy, and transformation T of 2 maps figure G copy onto figure G copies copy. The transformation that maps G onto the copy is called the composite of T of 1 and T of 2, written T of 2 following T of 1. The symbol, the circle thing right here, is read following, and in the activity Rx came first and then our y equals x, so we write r y equals x following Rx, and that's how you'd say it. Or you could say the composite of Rx and ry equals x. To describe r y equals x following Rx, one transformation considering the results of the previous activity, quadrilateral A, B, C, D is the pre-image, the copy is the first image, and then the copy of that is the final image. In step 6 of the activity, you plotted only the pre-image A, B, C, D, and the final image to get a graph like the one at the right below, which is this graph right here. This is the original, the copy of that, and then the next copy. The graph shows that the composite is a rotation of 90 degrees counterclockwise around the origin. We denote this rotation by r of 90. This rotation is the composite of the two reflections. R of 90 equals r of y equals x following Rx. And then in geometry, you should have encountered the two reflection theorem for rotations. The composite of two reflections, r of m following r of l over intersecting lines. L and m is a rotation whose center is the intersection of L and m. The magnitude of rotation is twice the measure of an angle formed by L and m, measured from L to m. Because the x-axis and the line with equation y equals x intersect at the origin at a 45-degree angle, this theorem explains what the composite r of y equals x following Rx is a rotation about the origin with magnitude of 90 degrees. And again, there's the graph, shows you how they did it. How can you find the matrix associated with r of 90? In steps 5 and 6 of the activity, you multiplied the matrices for two reflections, then multiplied the matrix for A, B, C, D on the left by the product. The result of the matrix for the copy in symbols, we can show this as follows. You multiply these two by this to get your answer, which this is r of 90 times the points of the original image gives you the matrix for the final copy. And this tells us that 0, negative 1, 1, 0 is the matrix for r of 90. The general idea is summarized in the following theorem. If M1 is the matrix for transformation T of 1, and M2 is the matrix for transformation T of 2, then M2, M1 is the matrix for T of 2 following T of 1. And for the example, golfers strive to achieve the elusive perfect swing. Assume that when looking at a right-handed golfer from the front, as the golfer begins to swing, the golf club rotates clockwise about a point near the tip of the shaft. The club starts from a vertical position at setup, then moves along a 90-degree arc until it is horizontal at some point during the backswing. The rotation is R of negative 90. For the left-handed golfer, the rotation will be counterclockwise, or R of 90. The pre-image golf club and the image golf club are pictured in the graph below at the right. The 3 points on the original golf club are P 1, 0, G 1, -6, and A 2, -6, and use matrix multiplication to find the image of PGA under R of negative 90. Okay, since we don't have the graph, I'll draw that out. It's not working. Hold on. Okay, there we go. Okay. Going by twos here. Okay. So the first point P is 1, 0. So put a point right here. So I went by twos. The next point is 1, -6. And then 2, -6. So this is the golf club. Oh, jeez. It's kind of hard to draw on this. There we go. Okay. So there's the golf club. And now we want to find what the golf club is like when it's in the backswing horizontal and parallel to the ground. A counterclockwise rotation of 90 degrees is a composite of two reflections given by R of 90 equals R, Y equals X following R of X. So to find R of 90, or R of negative 90, a rotation of 90 degrees clockwise around you need to do around the origin. Okay. So you need to measure the angle formed in the opposite direction with the line with the equation y equals x. So first you have to reverse the order of the composition. So instead of so the original one was R 90 equals R Y equals X following R of X. And so our reversed one is now R negative 90 equals, then you just flip these two to get the reverse. So R of X following R Y equals X. Okay. And now we can get the matrix for R of 90, which we did earlier. So I don't need to multiply, I'll just, it's 0, 1, negative 1, 0. And here, I'll put these up here so you can just see that, what they are. R of x is 1, 0, 0, negative 1, and this one is 0, 1, 1, 0. So that's how we got our answer for this one. And now to find the image of the club PGA, multiply its matrix by the matrix for R of 90. So our matrix would just be the points, so P, G, A, that's times. Okay. P was 1, 0. G was 1, negative 6. And A was 2, negative 6. Okay, so since we have this, our answer is going to be flipped at the end. So with it being flipped, we'd have, or let me put these up here, P, G, A. Okay. So first we would do 0 times 1, 0, negative 6 times 1, negative 6, and negative 6 times 1 is negative 6. So that's the top. And then for the bottom, would be these ones. 1 times negative 1 is negative 1. 1 times negative 1 again, negative 1. And 1, or negative 1 times a negative 2. Okay, sorry. Negative 1 times 2 is negative 2. Okay. So there is our new point. And I'll put those on the graph. So 0, negative 1, right here. I think. Yeah, right here. Okay. Yeah. And negative 6. So right here. Negative 1, right here. And then negative 6 again, and negative 2. So there's our golf club when it is in its backswing. See how this is it, and then we rotate it, negative 90, and that's it. So yeah, hope you learned something.